Hello everyone and welcome to this video on memory hierarchy and different types of memories. This is the series of videos under the course of digital design, in the Department of Electronics and Communication Engineering. So coming to this, this is the first video for this unit 2. In this video, we will be discussing on what is a memory hierarchy, and then we'll be discussing on the different types of memories available over here. Yeah. So objective of this lecture is to help the students to gain knowledge in memory hierarchy and different types of memory. So first of all, what is a memory hierarchy? What do you mean by a memory hierarchy? Why? What did would be the hierarchy of here in the memory? So first of all, hierarchy is nothing but a level or the approach where bigger system. I mean to say, if you want a very huge memory, it is not possible at a one shot. It will be divided into subpart. We say it as a hierarchy. That is the actual definition of an hierarchy. Now coming to the first one, memory hierarchy in a computer system, it would be there would be a main memory, the memory unit that computes directly with the CPU, that is a raw RAM memory. Then there would be another memories which are like auxiliary memory. Like you can save it in an external devices, like I mean to say in the system itself, you can have an disk drives, that is an auxiliary memory, or you can have some cache memory which is used for storing an intermediate data. Even the auxiliary memories can be like any other devices, like storage tapes or magnetic tapes or all those one. That would be discussed in the subsequent classes. So the main memory or the memory would be consisting of, when you say, when you go for a memory, so a memory unit would be just like an, the memory would be there. Whatever the memory, suppose let's take 1 MB of memory. So in this one, you would be having for every memory or a memory cell, you would be having this the output data lines. This is the data. So you would be having address lines to this one, and you would be having some control lines like read data or write data, read, write, and this is let's say chip select. So these are the different functions of this one. So once you give chip select as high, it will go for selecting this memory. Then provided an address, any address data would be taken up, and the how many bit data is there, that is the number of output lines, and how many addresses you can address. For suppose per M1 MB you will be having 20 20 lines of address lines, then you can address up to 1 MB. So that would be one part, and using of a different way you can even go for addressing the memories. So this address bus, you can have an 16-bit address bus, but you can have a larger memory. So this is possible by having a different type of addressing it up, but by selecting one of the memory out of that one, then we are reading over that. So that is the one part of memory segment. So here for any memory, you will be having address lines, output data lines, on chip select line, read and write. This is about the memory, and the memory hierarchy. You can see it on the screen. So you would be having magnetic tapes, the memory hierarchy. This is the auxiliary memory side. These all are the auxiliary memories: magnetic disks, magnetic tapes. So this would be the main processor, whatever the CPU processor. So you would be having the main memory and cache memory. This is taken into consideration once you are going to read the data from the CPU. You will be going for this one. So this is the cache memory and all this. So this is the memory hierarchy which is available in your any microprocessor system. Coming to the classification of memories. how the memories have been classified. So the functional classification of memories have been done in these different categories. The first one is depending on the types of memories. So you would be having an registers, memory, main memory, and secondary memories. This would be the first category. And the same, you can access the memory in sequential access or random access. And then the type of the memory which is used, when you said storage of it would be a static storage type. It would be a static or dynamic. The memories may be a volatile memories and non-volatile memories, and the material used to uh, save the data. It may be a magnetic or semiconductor. So what how the classification is being made? We'll be discussing one after the other. First, we'll go for registers, main memory, and secondary memory. The registers are just you would be having either a 16-bit registers or 20-bit registers or 32-bit registers, whatever it is there. These registers are used to handle the ALU operations like addition operations, subtraction operation, or any other operations within the CPU. Handle all the CPU operations will be having registers. So, for example, if you consider a microprocessor like 8086, you will be having 16-bit registers like AX, BX, CX, DX. All these registers are within the CPU. So that is it is used to handle the ALU operations within the CPU. It is a registers. The next one comes about the main memory. Main memory is used um, to store the data or the program instructions within the main memory. That is the main memory concept. And secondary memory is connected outside it, like magnetic tape, magnetic drums, floppy disk, and hard disk. So these are the secondary memories. So you will be having registers, main memory, and secondary memory. And coming to the sequential access memory and random access memory. So this is the how you are going to access the memories. Either you can access the memories sequentially, mean to say one word, next second word, like that way it will proceed from the first word to the last word. So if you want to read some kth word, so first of all you need to read the first k minus one word, then only you can read the kth word. This is about the sequential access memories. So here you have given an example like if I want to go for reading the kth word, some kth word. So what you need to do is that the starting k minus word have to be read first. You need to read the k minus one words, then only the kth word can be read. This is about the sequential. But when you go for the random access, so whatever the word, wherever the word is there, like say the first 10th word you want to read it up, directly you can go to the 10th. It is not required that the first 9 words has to be read in random access. But sequential access, you need to read all those words. So that is the difference between random access and sequential access memories. So sequential access memories are usually very slow in nature. Next comes is the static memories and dynamic memories. So this is about retaining the data. Once you power off is there or refreshing is there. So there would be two types. Static memories means the data would be retained as far as the power is being maintained, the data is there. But dynamic memory is in such a way that once you read the data, the next moment again the data is being refreshed. So every time the data is being refreshed in what? Dynamic memories. But in static memories, the data is being stored. It is saved. Okay. So you have heard about static RAMs and dynamic RAMs. Static RAMs and dynamic RAM is nothing but in dynamic RAM the data has been erased and again it is been refreshed with a new data every time. Once you are reading the data, next moment it will loses it will remove the data from the dynamic RAM. But in static RAM, the data would be kept until and unless the power supply is been there. So once the data is been filled up in the RAM, what we need to do is that either you need to restart that system, or some process should be there that the data has to be removed from the RAM. So that is the difference between static and dynamic RAM. Next comes is that volatile and non-volatile memories. So volatile memories are, it loses its contents when no power supply. When there is no power supply, all the contents in the memory is been removed. And non-volatile memory is that even there is no power supply, the data is being kept in the memories. That is called as non-volatile memories. Volatile memories, it will loses its contents when there is no power supply. Or more or less, we can say static memories and dynamic memories. Static memories are also said to be volatile memories. But dynamic memories are not non-volatile memories. Non-volatile memories are the memories even there is no power supply also, the data is in there. This is about the non-volatile memories. The chance is that the type of material used to store the data. So in your semiconductor memory and magnetic memories and semiconductor memories. The material used to manufacture the memories is semiconductor material. We say it as a semiconductor memories. And the material used to store the data is a Teflon material is being used. It is called as a magnetic memories. So this is about the magnetic and semiconductor memories. So you will be having lecture level problems like classify the different areas of memories based on functionality, and classify the different types of memories and based on the hierarchy. By the outcome of the lecture is that on the completion of this lecture, students are able to classify memories easily and able to explain the memory hierarchy. Thank you. We'll have a detailed discussion on the next one in the next coming